Hey there, Jakub here for Capturing Reality. I am happy to announce that RealityCapture 1.2 Tarasque is now available for download. This massive update is filled with performance increases like the faster depth map calculation. Next we have a new ribbon and user experience changes, and it's packed with brand new features like orthomosaicing, contours, measurements, and much more. We'll walk you through the new image mosaicing rendering method for creating orthoprojections. We will talk about generating contours from digital surface models or digital terrain models. We will use the new drawing tools to calculate areas, volumes, and to create height profiles. And finally, we'll go over image mosaic editing with the new drawing tools. With that said, let's get started. This is our finished project with all of the results, and I will use it to demonstrate all of the mentioned features. It is created purely from drawn images, and it is accurately georeferenced with 6 ground control points. This entire project would cost around $4 with the PPI license. So the first thing we're going to do is to check the updated ribbon and other changes to the user experience. In previous versions of RealityCapture, we only had one context tab. Now we have a new context ribbon that has 2 tabs for each open view. Now we can see the 2 for the scene 1D and 2 for the scene 3D. The first context tab deals with the visual part, and the new Tools context tab contains all of the tools that can be used in the selected view. Some tools from the Alignment tab and Reconstruction tab were moved to the Tools tabs. Context tabs also change color based on which color cursor is assigned to the selected view. Here I am switching between blue and green. When I open this orthoprojection, also a new context ribbon will open automatically. However, it is not possible to open context ribbons of the same kind. So if I change the view to be 3D, only one scene 3D context ribbon will be visible. Color cursors were also significantly updated. Now when you assign them to objects, the layout automatically adjusts and opens new views. Let's assign color cursors to a few images. Hold down 1 key and left click for blue, 2 plus left click for green, and 3 plus left click for magenta. As we can see, the layout changed as we were assigning color cursors to images. RealityCapture now remembers the last assigned color cursor, and we don't need to hold down number 3 to assign magenta again. Previously, the default color cursor without any shortcut was blue. Now to assign blue again, we need to hold down 1 plus left click. Color cursors are also respecting the new parent-child hierarchy. So let's select this orthoprojection for example. This orthoprojection has 3 sub-objects, which are these 2 regions and this line. When we select the line, the next color cursor, which is green, will be assigned to it, and the height profile of the line is displayed in the green 2D view. Blue is my parent, and green is the child. Color cursors are also respecting sibling structure. If I select one of the regions, the green cursor will be assigned to it. Of course, I can add additional color cursors. If I hold down number 3 key and select this region, it will be assigned magenta, and it will be displayed in the magenta 2D view. By now you might have already noticed some changes to the view type or the view aspect selector. Let's make this a little easier and switch the layout to 1+1 with a large map view. When we press the button, we get this list of options which are now color-coded. The first 2 rows are dedicated to the currently assigned cursor object, which in this case is the orthoprojection. We call it dimensionality of the cursor object. The orthoprojection has 1D information, and it can also be displayed in 2D. Now I will switch back to the map view. The second 2 rows are dedicated to the current view. This is the dimensionality of the currently viewed object. The map view also has 1D information and also 2D information like the orthoprojection. Note that a cursor object can be a view object at the same time. In that case, we have fewer options in the menu. What comes next are called shortcuts, so they serve to switch between 2D scenes, 3D scenes, 4D scenes, and map views. Those are basically independent views. The last category are special views, which contain the console and the help. So those were the biggest changes. There are also some small changes. For example, the Reconstruction tab was renamed to Mesh Model, and we now have a brand new one export, which can be used to export all of your creations from one place. It can be accessed through the Workflow tab, or when you click on the RealityCapture icon. Besides the export, we have an option to share the results online and also to generate reports. In the one export, we can search for the desired export option we're looking for, and RealityCapture also remembers recently used formats which can be cleared if we want to. That would be a brief introduction to the new user experience changes, and now let's dive into the new features, starting with cross-sections. A prerequisite for generating cross-sections is to have a model. When the model is created, the tool can be found in the Scene 3D Tools tab. When the tool is activated, it opens a widget that is similar to the orthoprojection widget. Besides the usual editing options, this widget allows us to set up the cutting plane direction. By default, the cutting plane is set to be horizontal, but by clicking on these squares, we can change the direction. At the same time, the widget displays a ruler that allows us to see a preview of the cross-sections by hovering the mouse cursor over the ruler. The first cross-section starts here from the starting point that is indicated by these red arrows. Now let's take a look at the cross-sections panel. The cross-sections panel in the 1DS is very simple. It has only one setting that can be changed, and that is the distance between cross-sections. The value is in the project coordinate system units, so in our case, meters. Based on the interval, RealityCapture will calculate the resulting number of cross-sections. When the interval is changed, also the ruler is updated in the 3D view. So if we type in 10 meters, the resulting number of cross-sections will be 22. When we are satisfied with the preview, we can create them. After the computation, we can disable the tool and turn off the visibility of the mesh so we can see them better. We can also disable the cameras by pressing Ctrl-E. They are automatically displayed after the computation, but if we would like to disable or re-enable them later, they are a child object of the model and they can be found here in the 1DS. They can be turned on or off by clicking on the eye icon, same as the mesh. If we select them, we get a new option to change the display step of the already computed cross-sections. Right now, every cross-section is being displayed. If we change the step to 2, only every other cross-section will be displayed. Cross-sections also work with the clip-in box. They can be exported from the Mesh Model tab, Scene 3D Tools tab, or through the new One Export. Cross-sections can be exported to CAD software in DXF format or to GIS software in shapefile format. That will be all about cross-sections. Let's move on to image mosaicing. In previous versions of RealityCapture, we could only render a true orthoprojection of a colored or a textured mesh. From the user perspective, an image mosaic is generated the same way. We just need to change the rendering method in the orthoprojection tool. The orthoprojection tool is located in the Workflow tab, in the Scene 3D Tools, or we can use the shortcut F11 to activate it. Now we need to change a couple of settings. We want to create a map, so we need the type to be from the top. Remember that map GPS type always creates an orthoprojection in WGS84 coordinate system, which is good for KMZ export. But in our case, we want to use a different coordinate system, so that is why we select top. Next, I will expand this info panel and make sure that the coordinate system is set correctly. So in our case, yes, it's fine. Next, we will change the rendering method. In previous versions of RealityCapture, we only had the true ortho from a colored model or true ortho from a textured model if the model had textures. Now we have two more options. We have image mosaicing general for arbitrary or general datasets, and image mosaicing aerial for a drone dataset like in our case. Next is the ortho pixel size. If we click on estimate, we get the best possible resolution, which is around 5 mm. But for our needs, 1 cm will be good enough. When we type in 0.01 meters in the ortho pixel size, the width and the height of the orthoprojection will also be updated. Another setting worth mentioning is down here. Generate digital terrain model is automatically turned on when the model has an existing classification. The classification was created using the AI Classify tool, and it was manually edited so the entire site is classified as ground besides these two cars, this shack, and the bulldozer. They were added to the artificial object class. Back to the orthoprojection tool, here we can choose a classification for the digital terrain model. In our case, we only have this single classification number 0. The main reason why I'm mentioning all of this is that image mosaicing works best on digital terrain models. Digital surface models will cause unwanted double projections. Now all that would be left to do is to click on render, but I already created a mosaic and a projection from a texture model for comparison, so we don't waste any time. Image mosaicing doesn't require the model to be textured or colored. It seamlessly stitches certain parts of the input photos to a huge image that is projected on the digital surface model or on the digital terrain model. Let me show you what I mean by that. We will go to the Ortho 2D View Context tab. Now we have a new input layer called mosaicing. When we click on it, we can see the entire mosaicing scheme displayed in the 2D view. Or we can switch back to the image layer and display the mosaicing scheme as an overlay. Each tile represents a part of a certain image. We can even select individual tiles and also add color cursors to them. We can see exactly which part of the image was used for this tile. You may ask what is the benefit of this method, and the benefit is increased quality of the ortho projections. We can do a quick comparison with the true ortho projection from a model. Let's check them side by side. Let's disable the mosaicing overlay for this projection, and let's assign the green cursor to the second projection from the texture model by holding down the number 2 key and clicking on it in the 1ds. Let's zoom to these cars because I found them to be a good example. Both projections have the same ortho pixel size of 1 cm, and the model was also textured with a custom fixed texel size set to 1 cm. The difference in quality is obvious to the naked eye. Alright, that were the basics of image mosaicing. We also need to cover mosaic editing, but we will get back to it once we take a look at the new drawing tools. Up next are the contours. To generate the contours, first we need an ortho projection. Before you generate any ortho projection, make sure that it is in the correct coordinate system because the contours will share the same coordinate system. The contours tool is located in the Ortho 2D tools right here. To activate it, we will simply click on it, and this opens the contours tool panel, which is paired with this projection. Now let's take a look at the settings. First we have the pixel type. I can choose between altitude and depth. We are creating maps, so as surveyors we are interested in the altitude in this case. Next we have the input layer. We can choose between the DSM or the DTM. DTM option is not always available, only if it was generated, which it was in our case, so that is why we are preferring it. We want contours to be generated from pure terrain without any artificial objects. Units are pre-filled according to the used projection and its coordinate system. It cannot be changed, and this is not present if the ortho projection is not georeferenced. Then we have interval, which determines the vertical spacing between contours. Right now, it is set to 1 meter. Final settings are for minimum and maximum. These numbers are pre-filled according to the minimum and maximum value of the ortho projection, but we can change them if we would like to. Altitude of the first contour is equal to the minimum, and maximum value is just the upper bounds. If we are happy with the settings, we just press compute. Every fifth contour is highlighted, and if it's long enough, it will also have a label. So, for example, this contour has 250 meters above sea level. In the Ortho 2D tab, it is possible to toggle between black and white color of the contours. White is default for the image layer, and black is default for the DSM and DTM layer. By the way, DSM and DTM layer now support slope shading. Like cross sections, contours can also be exported to CAD software in DXF format and to GIS software in shapefile format. They can be exported from the Ortho 2D Tools tab or from the One Export. With the contours out of the way, we can move to the new drawing tools and measurements. Like in the case of contours, a prerequisite for drawing tools and measurements to work is an ortho projection and one 2D view. As before, the tools can be found in the Ortho 2D tools. To activate them, we will click on Measure. Now the drawing tools are active. Before we move on to volume and area calculations, let's get familiarized with the basics of drawing tools. We can pick from a number of drawing tools. My favorite is the polygon because it can be easily edited. We will go over editing in just a bit. To start drawing, just left-click with the mouse. Additional vertices are also drawn with the left mouse button, so we'll continue to create a polygon around this entire pile. If we make a mistake, we can remove the last vertex using the right mouse button. To cancel the entire drawing, press Escape, and to close the shape we have 3 options. Move the mouse cursor near the first vertex, it will snap to it, and now we can just left click to close the shape. Instead of snapping to the first vertex, we can snap to the last vertex and again close the shape with the left mouse button. Or we can just double click to place the last vertex and close the shape. After we close the shape, a new panel appeared in the 1DS and a new 2D view appeared displaying the height profile along the boundary of the shape. We will check them in a while. Let's draw another shape with the brush. We can draw with it and change the size of the brush like in other photo editing software using the square brackets on the keyboard. We can also use it with modifiers on selected regions. Hold down Ctrl to add to the region, a small plus sign is visible in the brush, or hold down Shift to subtract from the region and a small minus is visible in the brush. Shapes like polygon, polyline and the freeform shape can also be edited. Let's quickly draw another polygon. Now let's disable measure and let's enable edit region. I can select multiple polygons and edit them all at once. Let's select the second one by holding down Ctrl and clicking on it. There are 2 options how to select vertices. First option is to simply click on them. We will see that it is highlighted. To select additional vertices, hold down the Ctrl key and left click on multiple vertices. We can also select vertices from another polygon if it is selected. The Shift key can be used to remove vertices from the selection. Another method of selecting vertices is using one of the drawing tools. In this case, only the vertices will be selected and no new shapes will be created. Let's try the freeform shape. Now we can move the entire selection of vertices by clicking in proximity of one of them and dragging the entire selection like this. Selected vertices can also be deleted with the delete key. To add new vertices, we need to get close to an existing edge and press the left mouse button. Before we move on to volumes and area measurements, we need to take a look at snapping. Snapping is done by holding the left Alt key. Let's start drawing a new polygon. With the pressed left Alt key, the mouse cursor will now snap horizontally or vertically. It can also snap to control points, to vertices, or edges of existing regions. Finally, it can snap perpendicular to the last segment. All of the snapping options can be controlled in the snapping panel that can be turned on here. By default, all of the options are turned on. Definitely try to play with all of the drawing tools, and now let's move on to measurements. When I finished the first polygon, I mentioned that a new panel opened in the 1DS. Let's select the polygon and get back to it. In the panel we can see the name of the region and its color. Both can be changed if we want to. Next we have the volume info and area info. The area info is self-explanatory. It contains the calculated 2D area and 3D area. The volume is calculated with respect to something we call the base plane. Everything above the base plane is considered as part of the cut volume. Everything that is below the base plane is considered as part of the fill volume. There is an option to visualize the base plane in 3D, so let's open the 3D view and change the rendering to vertices. Currently the base plane type is set to interpolated, and we can see that the base plane is pretty reasonable in this case. There are multiple options for the base plane. Each method has its pros and cons, so they are suited for various situations. When it is set to none, the volume will not be calculated. This is good if you want only the calculated area, or to edit the region, but you don't want to recalculate the region every time you move a single vertex, because it takes some computer resources. Interpolated creates a base surface by interpolating the terrain in the selected shape. Flat and minimum and maximum height method has 2 base planes. The bottom plane is at the lowest point of the shape boundary, and the top plane is at the highest point of the shape boundary. Based on this, the cut volume is calculated from the bottom plane to the surface of the model, and the fill volume from the top plane to the surface of the model. We can see that in this case, the bottom plane doesn't suit us because the surface is sloped. Sometimes we do not want the top or the bottom but manually specify the height. That is exactly what flat at user-defined height enables us to do. It works amazingly well with the height profile, where you can get the height of any point along the boundary. Finally, there is the best fit plane. The best fit plane uses linear regression to calculate a flat plane from the boundary of the shape. It's time to take a look at the height profile. Let's switch the right view to 2D to display the profile, and let's enable and select this line number 1. The height profile has 2 axes: position along the boundary and height. Right now, their scale is 1:1, but we can change the scale of the height with the mouse scroll wheel, like this. Notice that when we move the mouse cursor over the height profile, we can also see a cross moving along the line in the left 2D view. Simultaneously, the height profile shows the exact position and height of the cross. Just a couple of notes before moving on. It is possible to select multiple regions to get the sum of the volumes and areas. Regions also work with color cursors. They are part of the selected ortho projection report, and they can be shared between projects same as the reconstruction region using the export shapes and import shapes options. Coming up next is the mosaic editing, which I already mentioned several times. Now we have a different project which will better demonstrate the power of mosaic editing. It is a road mapping project, and we'll remove this car from the ortho mosaic because we do not want any cars present. To activate the tool, we need to select this 2D view with the ortho projection, go to the Tools tab, and here we have Enhanced Mosaic. It works similarly as the volume and surface measurements. First, we'll draw a polygon around the car and its shadow. After the polygon is closed, the layout changed and a new special 2D scene view opened, which is associated with the region. Under the Mosaic in 1DS, we have a new mosaicing node, and it's containing our new region. The new 2DS contains 3 groups of images: active, suggested, and disabled. Active images are the ones that are being used for the region right now. Now we have just one image, but if the region was larger, there could be multiple images projected in that region. Suggested images were picked by the algorithm, and they can replace the currently projected image. The disabled section is just for us to store images that we don't want to consider anymore. Images have to be dragged and dropped between these groups. First, let's move the currently active image to disabled by drag and dropping it. When we hover the mouse cursor over the suggested images, they are previewed in the region. Let's pick one, for example this one, and drag and drop it to the active group. One tip: if we had multiple original images in the active group like this, double left clicking an image will override all of them and move them to the disabled group. It looks good enough, so let's apply it. If you worry that the colors or the brightness doesn't match entirely, we don't have to worry about that because color correction will be applied to the region. To apply it, let's hit Bake. This Bake button is located in the Mosaic editor view, so the special 2DS view needs to be opened and selected. We can choose if we want the projection to be applied on DSM or on DTM. As I mentioned earlier, the preferred method is the DTM. DSM can cause double projections. Now let's click on Bake, and after a while we will see the result. Now we can delete the region, and in the Ortho 2D view, turn on Mosaicing Overlay. Here we can see our new tile. As you have seen in this tutorial, RealityCapture is more capable than ever for surveying jobs. We can easily classify the model and create digital terrain models. Then with just a couple of clicks we can generate orthomosaics, cross-sections and contours. And as was just shown, the new drawing tools are great for measurements and editing the orthomosaic. But this is not all. Definitely check out the changelog and try out all of the new features like the misalignment detection and cut by box. Thank you so much for watching, and I'll see you in the next one.